Hello everyone, welcome back to premium course Steel Warehouse Design BSc. Now let's continue to verify raster. After we complete verify steel column, now continue to verify raster. You can show the analysis result in the analysis option, or you can directly check the member, and this is the design value, the internal force. You can apply all the external force in Excel set or in particular tense. Now I use my Excel set to verify, and the moment measure C, we input it in Excel 483.9 kN, and the shear is 36.4. Yes, it's complete. And the section is IPE 500. Change it here. Strength of the material or grade of material is 275, and the design ratio is 0.8. Come back and take the mouse over to check. The design ratio is 0.8. For the fully restrained top and bottom, to prevent lateral torsional buckling occur on the steel beam or on the raster, we design and check for the capacity of the section compared with the applied moment only. 80 in noise. We ignore the lateral torsional buckling occur in the steel frame. So you can verify, this is verify for the section only, not include LTB. You ask me why we do not include LTB. Okay, now let me show you if I include LTB in this result. Okay, now let input the parameter. Check. Yeah, the distance is 12.25. Now I input it is 12.5. Yes, it's correct. 12.25. Now let me change it to 25. Okay, and the restraint, we start the first point is 0.4 meter. You can check 0.4, and after that is 1.64. Now let me check the result in the class structural designer. Right click, check static, check for the buckling lateral torsional. So the LTB is equal 0.4. Yeah, this one is 0.4. But now in my model, I will assume it 1.64. I assume it from here to here. 1.64. So input the value is equal 1.64 divided by 12.25. Yes, 12.25. Enter, and you check the result. You see the result include the lateral torsional buckling. Also the same with the result, compare only the capacity of the section is 0.8. Okay, 0.8. This is why I tell you, when the beam is fully restrained, to again the buckling, lateral buckling, so we do not need to include lateral torsional buckling in verification of the steel beam. We design the section capacity verified with the applied moment. But in my Excel set is not complete because we do not take into account the actual force into the design procedure. In the class structural designer also include the actual force, because actual force with the moment we can calculate the interaction in other. So the capacity of the section will be changed when we include the axial force combined with the bending moment. So my XZ verify only for the moment. Yes, not include axial force. I hope you enjoyed this tutorial. For more detail, ask me directly in the group. Thank you for your watching. Thank you.